Hello everybody. This is our video solution to problem 3 from the Fall 2020 Math 210 final. In this problem, we are trying to maybe not actually compute an integral, but put some sort of bounds on it, right? So here we're trying to compute, or at least understand, approximate, what have you, the integral of e to the t squared from 0 to 1. And what we're asked to do is just show that the value of this integral lies between 0 and 3. And if we don't read the instructions, we might be tempted to try to use the fundamental theorem of calculus on this. Now, there's two very good reasons not to do so. Reason number one is that the instructions tell us not to do so. That's always a really good reason. Number two, we aren't going to be able to anyway, even if we wanted to. Why? Because e to the t squared has no elementary antiderivative. Okay. Clever Carl, right? Our good old friend, Clever Carl, he thinks there is one. He looks at e to the t squared and says, I can integrate that. I'm going to guess it's e to the t squared. Oh, that doesn't work. When you take a derivative, the chain rule gives you an extra 2t, so I'm going to divide by 2t to compensate. Okay, this does not work. How do you know it doesn't work? You just check. How would you check? Well, if this is really an antiderivative, then you could take the derivative and get e to the t squared. And what's going to happen when you start taking this derivative? I mean, you don't even have to go through the whole thing. You just say, well, quotient rule. Oh, like the bottom is going to be over 4t squared. Like there's just no hope, right? There's no hope that this is going to work out. Okay, so don't even bother finishing this, right? Clever Carl, wrong, wrong again. So what are we supposed to do? We can't use the fundamental theorem of calculus. Well, it tells us, right? It's right there in the instructions. We want to view the integral, right? View the integral as accumulation. All right, so this function is accumulating stuff, right? If we tried to graph it, maybe we don't know what e to the t squared looks like, all right? But we can say some things, right? At 0, you get e to the 0, which is 1. And what's happening? As t is getting bigger, well, t squared is getting bigger. But then e to that something is getting bigger. So it's going up, right? So if 1 is over here, this would be at t equals 1, you'd get e to the 1, which is e. All right, so there's that. And it's going to somehow grow towards it, right? We don't know what it's doing. But what we do know is that the integral is giving us the accumulation, right? It's just in this case, since this is a positive function, giving us the area under this curve. And so what we've really been asked to do is show that the area under the curve, that's what the integral gives us, is at least 1 and no bigger than 3, right? Actually, strictly greater than 1. Okay, but this is going to be pretty easy from the picture. First, if I just draw a horizontal line, I get it. I mean, it looks like a rectangle, right? Because I didn't draw this to scale, but this is a 1 by 1 rectangle, also called a square. All right. I know that the integral is greater than the area of this purple square. Okay, so the integral is going to be greater than the area of this purple square. Okay, which is a 1 by 1 square. Well, wait a second. The area of a 1 by 1 square is just equal to 1. Hey, that's what we wanted. Okay, now how do we get it less than 3? Well, note that the highest we get is at e. Well, e is about 2.7. Okay, well, we're trying to get to 3, so I mean, we could just go up a little bit. There's 3, and I could draw a nice line going across, and now I could draw this nice big rectangle. And I know that the area under this green curve is going to be less than the area under this blue rectangle, right? Or of the blue rectangle. And that goes from 0 to 1, from 0 to 3. And what is the area of a rectangle whose base has 1 and height is 3? Well, of course, it's equal to 3. So there we go. The area of this rectangle is less than the integral is less than the area of this bigger rectangle. 1 is less than the integral is less than 3. So we don't need to know any calculus, right? We don't do any of this crazy stuff. We just have to know how to interpret this symbol as an accumulation.